Highway bridges like this one are designed to support millions of pounds every single day, but how do they actually do it? Well, here's a quick lesson from a structural engineer on how bridges actually work. And the first thing you actually need to understand with bridges is which type you're dealing with. And there's many types of cool ones. I'm sure a lot of you guys have seen the suspension bridges or cable stay bridges. But the thing is, the type of bridge that keeps an engineer or contractor busy on a day-to-day basis is a simple I-girder bridge. This diagram gives a quick overview of all the different components into a bridge, but we'll be starting from the top and then work our way down since that's how the load is going to be transferred. Starting with the bridge deck, here's a bird's eye view of a bridge beginning. So you can see this darker pavement color turning into this lighter pavement color. That means the pavement is turning from asphalt to concrete because the bridge needs the extra capacity that concrete has to actually support itself. And you might ask why that is. So here's a shot underneath the bridge where you can see the girders are spaced like this to where there's a little pocket in between them. And that's where the deck slab needs to be completely supporting itself. And you can see the metal ribbing, that's actually called a stay-in-place deck form, and that's just what the deck slab is poured onto. So that brings us to our next component, which is going to be the girder. And these girders directly hold up the bridge deck, and they're typically made out of pre-stressed concrete or steel. So once the load travels from the bridge deck to the girder, it then goes into the pier, which is this big guy here. I'm sure you've seen tons of them. This one's pretty small, but they can get pretty big. Another super important component to know is at the beginning or the ends of the bridge, you'll have what's called an end bend. And they're pretty much the same thing as a pier. They just don't have the giant column, but they act in the same way where they transfer all the load from the bridge deck down to the girder and then down into the ground. So now going back to this diagram, because we need to see what's actually happening underground, since that's where a lot of the magic happens, we can see the pier transfers the load down to the pile cap and then into what's called piles. And these piles can go all the way down as far as 200 feet deep below the ground surface, just to be able to transfer that load into soils that are strong enough to be able to support all that load that's coming down from the bridge. Hopefully that was a good explanation. Let me know if you guys have any questions.